option is a main combined sewer was designed to serve an area of 60 square kilometers is given with an average population of this much. The average rate of sewage flow is given as 350 liters per capita per day. The maximum flow is given as 50% in excess of the average, together with the rainfall equivalent of 12 mm in 24 hours, all of which are runoff. Calculate the maximum sewage flow. We have to calculate the maximum sewage flow for the total population of the area. Total population is equal to population density, that is 185 persons per hectare, into 60 square meters is 60 into 10 to the power of 2 hectares, that is equal to 11.1 into 10 to the power of 5 persons. Therefore, we know that total population is this much. We know the average rate of sewage flow. So, average sewage flow is equal to 350 into 11.1 into 10 to the power of 5, that is equal to 388.5 into 10 to the power of 6 liters per day. That we have to convert into cubics, that is 385.5 into 10 to the power of 6 liters is 10 to the power of minus 3 cubic meters per day, 1 by per day 24 hours 60 minutes 60 seconds, that is cubics, that is equal to 4.5 cubics. Okay, stormwater flow. Here the maximum flow is 50% excess of average, together the stormwater flow. We know that stormwater flow is equal to area in square meters into depth of SRO in meters. The units has to be very important, and time of 24 hours in seconds has to be represented. So area in square meters 60 into 10 to the power of 6 into depth in 12 mm in 24 hours, 12 mm into 10 to the power of minus 3, that has to be represented in meters, 24 hours into 60 into 60, that is equal to 8.33 cubics. Therefore, maximum sewage flow has to be 1.5 times the average sewage flow. As we know the relationship between the average sewage flow and maximum sewage flow, we know that the value of average sewage flow is this much, 1.5 times the 4.5, that is equal to 6.75 cubics. Therefore, option A is correct. Question is, from the above question we have to find out the capacity of the sewer that we can design. So if you are able to find out the maximum flow, then we can say that as capacity of the sewer. So total maximum flow of the combined sewer is equal to maximum sewage flow from the above question plus storm flow, that is equal to 6.75 plus 8.33. Because we have already calculated the storm flow in the above question, so we are directly taking the storm flow from the above previous question. So that is equal to 15.08 cubics. Therefore, capacity of this sewer is going to be 15.08. Therefore, option C is correct. The question is, in the figure, two identical wires AO and BO, each of area A. Area is constant for the two wires AO and BO and inclined at an angle of 45 degrees to the horizontal. A load P is supported at O. So, if we consider the load in AO and BO is equal to, yes, So let the forces in each wire we have considered it as S. Resolving the force at O vertically, we have 2S sine 45 degrees is equal to P. Therefore S is equal to P by 2 sine 45 degrees, that is equal to P by root 2. Okay, and the total strain energy stored, what we have to find out, calculate the total strain energy stored. Total strain energy stored is equal to 2 into S square into 1 by 2 AE, that is equal to 2 into S is P by root 2 whole square into 1 by 2 AE, that is equal to 2 into P square L by 2 AE, sorry, P square by 2 into L by 2 AE, that is equal to P square L by 2 AE. P square L by 2 AE, option A. Therefore, option A is correct. Option is find out the vertical deflection at point O. So vertical deflection at O is equal to dou by dou P of strain energy at O. Strain energy at O. So from the previous problem, we know that the strain energy at O is given as mu I is, we got it as P square L by 2 AE. So by substituting this value in equation 1, we will get the vertical deflection at O. That is equal to dou by dou P of P square L by 2 AE. Except P, remaining things are constant. So L by 2 AE is 2P. That is equal to PL by AE. PL by AE, option B is correct. Is for a beam shown in the figure, determine the area of reinforcement required to have it as a balanced section. So sigma CBC is given as 7 MPa, sigma ST is given as 140 MPa. For 140 MPa, the X balance is equal to 0.4 D, that is equal to 0.4 into 550, that is equal to 220 mm. Depth of neutral axis, balanced section. For a balanced section, the force in compression is equal to force in tension, it is equal to sigma ST AST. We have to find out the reinforcement required. AST is equal to BX balanced sigma CBC divided by 2 sigma ST, that is equal to B is 300, X balanced is 220, and 7 2 sigma ST is 140, that is equal to 1650 millimeter square. 1650 millimeter square, option A is correct.